Code please.
Welcome to Code Please. In this channel, I try to teach you a little bit about computer programming using the Elixir language. If you find this content useful, please consider subscribing and sharing with your friends. Now let's get into today's video. Hi, in this video we explore processes in Elixir and Erlang, and how we can start to leverage the concurrent nature of the languages and virtual machine. We can think of the Erlang virtual machine as a box where a bunch of entities or processes live and send messages to each other. This kind of architecture can be somehow analogous to biology, where multiple seemingly independent entities collaborate concurrently to achieve a broader end result. Let's see how we can bring some of these entities to life and how they can talk between each other inside the virtual machine. The most basic way we can create a new process is by using the spawn function, which can take a function as an argument where the new process will do its work. Let's spawn a new process using the spawn function. And we're just going to ask this new process, to write something for us. We will just say, I am a new process. And then we end and we execute. And we can see that the process was spawned, it printed the string that we wanted it to print, and then it terminated. And the cardinal PID and the number that you see is actually called the process identifier. And it's the way we communicate with processes. It basically uniquely identifies that process inside the virtual machine. And we can do things with that identifier. For instance, we can ask the virtual machine if that process is still alive by calling the alive function on the process module. And it's going to say false because our process was a very short-lived process. It only printed that string and then immediately died. We can reference the currently running process because we are running an interactive Elixir shell, and this shell itself is a process. So if we ask self, we get the PID for this current process. Spawn can also take a module and a function to run, so we can easily define a simple module here with a run function. And inside this run function, we're just going to do basically the same. I am also a new process. And then we end the function, we end the module. And then we can run spawn my module with the run function, and we're just going to pass no arguments because that function takes no arguments, and we get exactly the same result as if we called spawn with an anonymous function inside. We can send messages to a process by using the send function. When a message is sent to a process, it gets stored in the process mailbox. In order to retrieve it, the process needs to call the receive function. So let's send a message to the currently running process, the interactive Elixir shell. The way we do that, we use the send function, and we basically tell it to which process we want to send the message, and then the message that we want to send. And this message can be anything. Typically, it's a tuple with any arguments that you want to pass into that particular process. And if we do this, we return the result of the message that we just sent. But the process itself did not consume this message yet because it ended on its mailbox. For it to receive this message, we need to actually use the receive function. And the way we do this is we define a receive block where we pattern match against any messages that we are interested in inside the mailbox. So in this case, I want to pattern match against hello and the message. I'm going to assign whatever was on the second part of the tuple to this message variable, and I will return this message. And for kicks, I will just also pattern match against something else, but this time this world, it basically will not match. So you shouldn't see this. You shouldn't see this string popping up. And if we end the receive block, we get world because we only sent it a message with the tuple hello world. It matched against hello message, and we printed out the message. This is a good point to also talk about tasks. Tasks are an abstraction on top of the spawn functions, and they basically provide better error reporting and introspection on what the process is doing behind the scenes. So let's try to raise an exception using the spawn function first. So we do spawn and we create an anonymous function that raises a hoops error. And we end it. And we can see we get a runtime error oops that occurred inside that particular process. You get the process identifier in there. And if we do it with the task, and task not only returns the PID of the process, but it also returns the tuple OK PID in case of the task succeeding to start. And this is already going to be very useful when we talk about supervision trees and other things like that. So we assign this to task.start. We pass it a function, and we also raise oops inside. We close our function, and I have a typo here. And if I execute this, I still get the same runtime error, but I get a little bit more information about which function gave the error and what arguments were passed into that function. In this case, no arguments. So we get a bit more introspection into how the background process executed. So far, we have spawned new processes that just execute a bit of code and then terminate. What about if we want a process to live for a while longer and possibly keep some state inside of it? Let's build a simple key value store like a map, whose contents are kept inside a new process. Then we can ask that process to add things to its state and also retrieve things we have stored before. For that, we can use a function named startLink that executes a certain function and passes the process an initial state. We can then loop indefinitely, waiting for other processes to make requests to add or get values from our state. In a small sense, we can already see how this is similar to a web server that replies to page requests from a web browser. This is only one of the many reasons I believe Elixir and Erlang are a perfect fit for the internet. So let's start by defining our key value store. We're just going to define a new module called key value. And we're going to define a function called startLink. And inside this function, we're going to do task.startLink with a function. And we're going to call another function called loop, which is going to be our main loop function. We keep calling this function to check for new messages on the mailbox. And we end. Then we finish this startLink function. And we define our loop that accepts the accepts the current state of the process, and it's going to be a map. We're just going to call it map, and for starters it's going to be an empty map, so no key value pairs in there, but then we can call the process to add and receive and get stuff from there. This function is only going to call receive, and if we get a message that starts with get and gets a key as well. And we also need to set up here the caller, so we can match against whoever is calling this this process, so another process in this case, so we can reference it later. And this is basically a message asking this process to retrieve one of the values that is inside our map. So we need to have a way to send back to the caller, and the way we have it is by matching against the caller as well. So now we can send a message to the caller, and what I'm going to send to the caller is basically map.get our map and the key, and map is our state in our process. And then after that I want to loop again with the same map. So we didn't change our internal state. We're just going to call the same function again to check for other messages and react to them. And another clause that we can get is the put clause, where we accept a key and a value. And in this case, what I want to do is call loop again, but I need to update my state. And to update my state, I just put on my map the new key with a new value. And if I close all these ends, I should get a module that can accept and retrieve values from a map. So let's give it a try. Let's start it up by matching against OKPID. So we get a reference to it, and we can do key value dot start link. This basically started our process and instantiated our map as its empty state. And now we can do, okay, send PID. I want to try to get the value for hello, and I'm the one calling. Okay. And if I flush my messages, I get nil. Flush basically calls the receive once for the running process. So since this works on sending messages back and forth, I don't immediately get an answer from sending that get messages. So I get the message into my mailbox. Let's imagine I am A and the key value store is the B process. So I send a message from A to B asking for a value, and then B is going to send a message back to me. So with the value, in this case it's nil, but nonetheless. But this message, I don't immediately see it because I, as A, need to call receive to get it. And we could do receive, or we can just call flush, and it will flush all the messages that I currently have. So I have the result of my query to the map process, and that is get me the value for the hello key. And in this case it's nil because the initial state of the B process is an empty map. But we can try to put some things in there. So let's do send to the same PID, which is the B process, the map process. And I can ask it to put hello and world in there. Okay. And if I do this, and now I try to send a get hello, and I'm the one sending it, and I flush again, I should have a brand new world waiting for me, because the current state of our key value store now contains a hello key and a world value associated with it. So we basically asked for it, and it sent it to our mailbox. As a final trick, because it sometimes can get a bit weird handling process identifiers all the way and keeping track of them, we can also register a particular process with a particular name for easier access later. So we could do process.register, and we're going to register this PID with an atom called store, for instance. And if I do this, then I can actually send messages. Instead of sending to PID, I can send to store, which is a more meaningful name. And I could do get and give me the hello value. I'm the one calling. And if I flush once again, I should have world again. I hope you enjoyed this little trip into how processes work in Elixir. If you want more information, make sure to check the links in the description, where you can find this and even more in-depth knowledge about processes and how they work. And I will see you on the next video. If you like this video, please consider subscribing and liking and sharing with your friends. It really helps the channel to grow. Thank you.